Okay. So with these two-step conversions, I like to use dimensional analysis. So we've talked about how I have that love of dimensional analysis. But you can use that chart that we talked about yesterday, whatever you're comfortable using. Now, tomorrow you have a quiz on the stuff, significant figures, dimensional analysis, okay, and on the stuff that we covered yesterday in class. I'm not going to put this that I'm doing today on there because you haven't had a chance to practice that overnight and come back and discuss it. So those are the three things that are going to be on that quiz. You can prepare a note card tonight that you can use on it. So you can have examples on it. You could have that graphic that's on my sideboard over there on it, if that's what you use to do these problems. So you need to have those things available on that note card to be successful tomorrow in class. Okay, does that make sense? And I've got extra note cards up here if you need them. And they're 3 inches by 5 inches. Oh, okay. Okay. So we are going to be converting. We've got our atoms here, or we're trying to figure out number of atoms. Okay. So I'm trying to figure out how to draw a straight line on this thing, you guys. There we go. A little bit better. All right, so I'm going to start out with my 55. I'm going to try to start out with my 55.2 grams of Li. I'm going to go from grams to moles, and then I'm going to go from moles to atoms. Go back and I grab my values. When I want grams for a conversion factor, where do I get those from? What tool do I use? Periodic table. So I'm going to look up lithium on the periodic table, and it's 6.9 grams per mole. The 6.9 goes with the grams, so that's going to go down here, and that's in every 1 mole. Then I'm going to go moles to atoms, and moles to anything is 1 to 6.02 times 10 to the 23rd. So we go to our handy dandy calculator and type in 55.2 times Avogadro's number divided by 6.9, and I end up with, and I need 3 sig figs because I had 3 sig figs here. So that's 4.82 times 10 to the 24th, and that's going to be atoms of lithium. So make sure that you can take your calculator and get that same answer. Because if you're not, we need to talk about how to use your calculator. And call me over. It'll just take me a minute to get that done for you, okay? Yep, times 6.02. Then you're going to put x, yep, 23 divided by, or hit equals, and then divided by, and now you're going to put in 6.9. Good? Okay?
I messed it up.
Okay. So, yeah. So let's clear that out. You're going to do the 55 point, whatever it is, 2, okay, hit times 6.02. And then you're going to hit that, yep, 23. Hit equals, hit divide, and put in your 6.9. Hit equals. There you go. Okay. 55.2. No. Put that right there. Yep, times 10 to the, yep, now type in your 23. Hit equals, hit divide, and then put in your 6.9. Hit equals. Yep. Well, that's why I want to make sure that you know how to use your calculator, okay? Because a lot of times your errors aren't because you don't know how to set it up, because you don't know how to use your calculator. And that'll just take a couple minutes for me to show you how to make it happen. Okay, so 6.02, or I'm sorry, no, the 55.2, I'm sorry, times, and I type in your 6.02. Okay, now hit this EXP key. That's going to give you your times 10 to the, and type in your 23 now. Nope, not 10. No, you're going to type in 23, because this is your times 10 to the. Now you're telling it what you're raising it to. Okay, hit equals, and then hit divide, and 6.9. And then equals. And that's the same answer I got up there. Okay, anybody else? Help anybody else? All right, so let's move on to the next problem. Any questions about this one before we move? All right. So the next one, and this will really tell us if you know how to use your calculator right. Because if you're still struggling getting this calculator to work for you, this is going to be kind of the bellwether kind of problem here. So this guy, we're going to start out with our 6.02. Oh, shoot. I'm going to try anyway. So 6.02 times 10 to the 24th. That's going to be atoms of bismuth. I'm getting rid of atoms. So I'm going to put atoms down here. And I'm going to go into moles. Then I'm going to go from moles into grams. All right. In 1 mole, I have 6.02 times 10 to the 23rd atoms. And in 1 mole, that equals 209 grams for bismuth. So if you look at bismuth on the periodic table, this is its mass on the periodic table.
So how did it become 6.02 times 10 to the 23rd power?
So this is my conversion factor.
Okay.
So just like in 1 dozen, we have 12, right? In 1 mole, we have this many atoms.
So is that where
they're just telling you that your sample has this many atoms in it.
But, wait, how did it go from 24 to 23? My question.
Okay. It didn't go from 24 to 23. Okay? No. Okay, so watch what happened here. Okay? This is your sample size. We're just using this as a conversion factor. So for example, if I had, like with our dozens, okay, if I had 240 items, okay, and I wanted to know how many dozen that was, I could go, well, I've got 12 items in every 1 dozen. Okay. And then let's say that for every dozen, it weighs 5 grams. So that's what we're doing here. Okay. This is the same idea as this, except instead of having dozens here, we have moles. Because we know in 1 mole, we have this many grams. We get this from the periodic table. This is just a standard value, just like in 1 dozen, we have 12 items. So we could calculate this, right? So 240 divided by 12. So that's 20 times 5. So that would be 100 grams. Okay. Does that make sense? Kind of what I'm doing with this? Okay. So when you calculate this out, you're going to hit this, you're going to multiply it by this, you're going to hit divide, and then you're going to put this in and hit equals. And this is what you should get for your answer. If you don't get that, I need to see you. You need to call me over and let me help you. Make sure you know how to use your calculator. Because a lot of times people will end up with like 10 to the 45th, though, or something like that. And certainly not 200 or 2090, which is a huge difference between those two numbers.
I just.
So you're going to type in. Okay, so we're here. So you have 60. So hit your. See that EE key right there? We need to activate that. So we'll hit second and EE. Now you're going to type in your 24 times 209 equals. Hit divide. Now you're going to type in this 6.02. You're going to do that second EE again and type in 23. There you go. Right. Anybody else not get 2090? So everybody else got that, right? No problems with it, no issues. Your calculator gave you what you wanted. Yes? Good? Everybody happy? Okay. Any questions on how we set these up? If you're using this method over here, you would be starting here. You're going this direction, so it would tell you to divide by Avogadro's number, which is what I did there. And then it told me to multiply by the molar mass off the periodic table. Okay? So if you're following these arrows, you could do it the same way. So here, we divided, and then we multiplied, just like this told us to. We divided by this, and we multiplied by this. Does it make sense the way you could do it with either tool, whichever way you prefer to do it? I prefer dimensional analysis, but you can do it your way. All right, so let's figure out the next one here. We've got molecules, and we're dealing here with alcohol. So we've got 2 grams of CH3OH. I need to figure out, I need to get rid of grams. So now I'm starting at the far end of that, and I'm coming towards me. Okay? So it tells me to divide by grams, and I've got to get those grams off the periodic table. So for this guy, I've got 12 for my carbon. My hydrogens, I've got 4, and I've got 16 for that oxygen. So that's 2 carry the 1, so 32. In 1 mole. And in 1 mole, I have 6.02 times 10 to the 23rd molecules. All right. Number, and we need 2 sig figs, so 3.8 times 10 to the 22nd, and that's going to be molecules of CH3OH. So make sure you can get that in your calculator. mentioned it. It's just where you've got two different hydrogens that come off, or three. So this would be like H2SO4. So you would use the first hydrogen here. And the second hydrogen here. Yes. Yep. Oh, yeah.
I feel a bit in my brain.
Yeah. So like H3PO4.
Shall we move from?
Yeah. All right. Did you get it? Everybody got it? Anybody need help? You rocking your calculators now? Good. Okay. This is a carbon from the periodic table. It's 12.
I got the move down.
The hydrogens are one each, and I've got 4 of them. And then the oxygen, I've got one of them at 6. Good?
Yeah.
Okay. Anybody else? We good? Everybody's happy? Okay. So the next one I think is where the dimensional analysis really kind of comes into play and really, really helps you out. So when you're working on a problem like this, I think dimensional analysis is really, truly your friend here. So if you've been using the dimensional analysis route, this is going to be great for you. So here we have a 6.04 gram sample of Al2 SO4 3. Now, we need to get rid of grams. We need to go into moles. Those moles then are not going to take me directly into atoms of oxygen. That's going to tell me how many of these we have, how many molecules we have. But that's not what they wanted to know. I did not make my line long enough, and now I'm trying to do it by hand. It's not good. So we need to take those molecules and then go into atoms of oxygen. Okay? So get your chart written down, and then I'll show you where I get all my numbers from. Top number, yep.
Yeah.
Yep.
From the bottom, stick to 6.04.
Nope, not here. This is grams. So anytime we have grams with one of these conversion factors, we've got to get that from the periodic table. So I've got to take 2 aluminum, and each aluminum is 27. I'm getting that from the periodic table. I've got a sulfur, and I have 1 times 3. I actually have 3 sulfurs here. 32.1 is the mass on the periodic table there. So that's 96.3, I believe. Yep. Okay. Then my oxygen, how many oxygens do I have?
4.
No.
12.
12, right. Okay. So I've got 3 times 4 is 12. So 12 times 16 from the periodic table is 192. So now I'm going to add those together. So that's my 54 plus my 192 plus my 96.3. That gives me a total of 342.3, and that's grams per mole. Notice this gram and the numbers, they are on the same line. So the grams are going to go here, 342.3, and that's in 1 mole. Now, in 1 mole, how many molecules do I have?
6.02 times 10 to the 23rd.
There you go. Yep. And I've got I even have like a little mole ceiling tile up there with that on there. All right. Now, in 1 mole of Al2 SO4 3, how many oxygen? So for every one of these, how much oxygen do I have in every one of these?
12.
12, right. So he got that by multiplying these together. And that then becomes your conversion factor to get you over to atoms. Yes.
So a mole will always equal 1, and for what you get from the mole, like molecules, it will always be 6.02.
Yep.
Okay.
Yep.
Just clarifying.
And that's why, like on the board up there, I like the one side you have to look at the periodic table for, but the other one, like that's just a number there. Do you see the convert, like with the arrows there?
Yeah.
Yeah. All right. So now we're going to plug this into our calculator. Okay. So how many atoms of oxygen? I have 3 sig figs, so 1.27 times 10 to the 23rd, and that's going to be atoms of oxygen. Good? Thoughts? Questions?